take a look at a lesson on more work with the sine and cosine functions. So you got introduced to that last lesson. Now we're just going to do some practice with this stuff, mostly evaluating. Okay, at the top it says the sine and cosine functions are the first a student typically encounters that are non-algebraic. That is, they cannot be thought of as a combination of a finite number of integer powers and or roots. Basically, x raised to powers. Those are thought of as algebraic. Square root of x squared, things like that. Sine and cosine are very different. Okay, so they're thought of as non-algebraic functions. They're actually called transcendental functions. Not something you really need to know, but that's what they're called. And that's all that we're talking about in this first sentence, okay? But in any event, let's pick up here. Since they are defined by using the geometry of a circle, they might not be all that intuitive. So a little bit of practice will be given in this lesson to get used to them. Okay. For exercise 1, recall the following definitions of the sine and cosine functions. If theta is an angle drawn in standard position, whose terminal ray passes through the point xy on the unit circle, then we recall sine of the angle goes with the y coordinate and cosine of the angle goes with the x coordinate. Okay, that's all that is getting at. Now down below, we're going to start evaluating some functions, sine and cosine functions, and what we'll do is we'll work off reference angles. So something that I find helpful to have, I'll just throw it on here, kind of off on the side, is this little table, right? So I'll put it right here. We're going to have 30, 45, and 60-degree reference angles, and we'll have sine of the angle and the cosine of the angle. So to me, this is a good thing to memorize, and then we use this to help us out when we got to do problems without a calculator. Sine of 30 was a half, radical 2 over 2 for the sine of 45, radical 3 over 2 for the sine of 60, and then the nice thing about cosine is it's the same values but backwards. Okay, we also want to keep in mind what quadrants we're working in as we do problems to determine whether or not the sine or cosine function we have is positive or negative, okay? And of course, we have our quadrantals from the unit circle. So let me just draw this up top here. 0, 90, 180, 270 degrees, back to 360, okay? And then again, since the radius of the unit circle is 1, these four coordinates become 1, 0, 0, 1 up top, negative 1, 0, and 0, negative 1. And again, sine goes with the y coordinate, cosine goes with the x, okay? So typically when we're doing stuff by hand with sine and cosine and evaluating these functions, we're either dealing with reference angles of 30, 45, and 60, or we're dealing with what are called quadrantals, which are multiples of 90 degrees. Those are the ones up on the unit circle. Okay, and this is what we got to work with. So let's take a look at number 2 here. It says, given the function f of x equals the sine of x, 6 times the sine of x, what is the value of f of 60 degrees? So f of 60 degrees, if we plug 60 degrees in for x, is just 6 times the sine of 60 degrees. And we have the table right there. Well, the sine of 60 is radical 3 over 2. So we have 6 times radical 3 over 2. 6 divided by 2 is 3, so we get 3 radical 3 at the end of the day, choice 2. Now, realistically, could you just take your calculator and punch that in if you're in degree mode? Yeah. Will you get this back? No, you'll get the decimal approximation, but then you could actually punch each of these in and see which one matched, okay, if you needed help with the multiple choice question. But ideally, look, we're working off reference angles and quadrantals, okay, that's all this stuff is. Next one, if g of alpha is equal to 4 cosine alpha minus 2 sine of alpha, then g of 330 degrees is what? Well, let's plug 330 degrees in for alpha and see what we get. So we're looking at 4 cosine 330 degrees minus 2 sine of 330 degrees. Okay, those aren't multiples of, that's not a multiple of 90. It's not a quadrantal, so it's probably going to be a reference angle. All right, so let's figure out what that is. 330 degrees is going to put us all the way into the 4th quadrant, and that's 360, so our reference angle here is 30 degrees, okay? So we're dealing with a 30-degree reference angle. Keep in mind what's positive and negative in each quadrant, okay? So I'm going to rewrite this. It's going to become 4. Now, the cosine of 330 is going to be equal to the cosine of 30, and it's going to be positive because we're in the 4th quadrant. So I'm going to replace this with cos 30. I'm going to replace sine with the sine of 30, but Since the original angle is in the fourth quadrant, the sine value is negative. So this becomes the negative of the sine of 30 degrees. Okay, when I take sine of 330, that becomes the negative of the sine of 30. Okay, now look, I think it looks like we got a double negative here in this product, so that'll become positive. And now we're looking at 4. I'll write it out like this, cosine 30 plus 2 sine of 30. And now let's figure out what those two values are for the trig functions. Okay, up top, cosine of 30 is radical 3 over 2, and the sine of 30 is a half. So simplifying the first, we're going to get 2 radical 3, and simplifying the second, plus 1. So it looks like choice 3 here. Okay, so again, all comes down to reference angles, what quadrant you're in, positive, negative, okay? Number 4, which of the following is not equal to 1? Notice every single one of these angles is a multiple of 90, so we're going to be more interested in this unit circle diagram for this problem. Which of the following is not equal to 1? All right, well, let's see, cosine of 0. At 0 degrees, the x-coordinate is 1. Okay, so that does equal 1. Cosine of 360, well, that's the same thing as the cosine of 0. That's also going to be 1. Sine of 90, I want the y-coordinate at 90. That is 1. Sine of 270 is the y value at 270, but that's negative 1. So the one that's not equal to 1 is choice 4 here. Okay. For angle alpha, whose terminal ray lies in the third quadrant, it is known that the cosine of that angle is equal to negative 0.96. Which of the following is the value of sine alpha? Okay. So, okay, for a problem like this, okay, with these random values, we have no idea what the angle is. We know we're in the third quadrant. What we can do is use our Pythagorean identity. That was sine squared of your angle, which they're using alpha here, plus cosine squared of your angle equals 1. That again was called our Pythagorean identity. Okay, so we know what the cosine value is, so we can use that to solve for the sine value. So I'm going to replace the cosine of the angle with negative 0.96. So sine squared alpha plus negative 0.96 squared equals 1. Okay, and no big deal here. We got our calculators. Let's figure out what that is. 0.96 squared. Negative 0.96 squared would be positive 0.9216. Okay, so let's subtract that from 1 to get the sine squared function by itself. And we're going to get 0.0784 here. Okay, and so now if sine squared is that, what do we have to do to both sides? Well, we got to take the square root of both sides. But we got to remember to put a plus and minus in front of the right-hand side, right? So what are we looking at? Taking the square root, we're going to get sine of alpha equals plus or minus, and now again, just use your calculator, take the square root of that value. Square root of 0.0784 actually comes out to be 0.28. Okay, so not too bad. All right, now looking at your answer choices, it should be obvious which one we're going to go with here, choice 1, because that's the only 0.28 that we even see out there. But why is it negative, right? Because we're in the third quadrant. You know, I could see positive 0.28 perhaps being a better wrong answer choice here, okay? So they make you think about the sign. Remember, when it comes to ASTC, if we're in the third quadrant, like we are here, the sign value is going to be negative. And so that's specifically why we get back the negative. Okay? All right, a special relationship exists between the trigonometric values of an angle and those of its reference angle. We looked at this in the unit circle lesson. This important relationship is illustrated here. Okay, in each of the following, an angle and its reference angle have been given. Using your calculator in degree mode, determine the sine and cosine of both the angle and its reference. Round all answers to the nearest hundredth. Okay, so we're going to look at the sine of 110 degrees on the calculator, and then we're going to look at the sine of 70 degrees on the calculator. All right, and then we're going to do the same for cosine. All right, so I'm just going to set these up, and then we'll punch them all in here. Okay, now they gave us the reference angles for these problems. We could figure that out as well, like for 110 degrees, right? That takes us into the second quadrant. And so it's another 70 degrees back to the x-axis. All right, that's what's going on with all of these. If we measured out to 235 degrees, we would see that that's 55 degrees back to the x-axis. Okay. Okay, so we'll start punching these in, all right? So sine of 110 degrees. Again, make sure you're in degree mode, that matters. Sine of 110 is about to the nearest 100.94. And if I then do the sine of 70, I get back 0.94. Okay, so again, notice they're the same. Okay, the sine of 110 is the same as the sine of 70. Why? Well, again, we're looking at the y value at 110 degrees. And whether I go up from the first quadrant or up in the second quadrant, it's the same exact thing. Okay, it's the idea here. All right, notice they're both positive because sine is positive in both the first and second quadrant. Now let's look at the cosine of 110. That is about negative 0.34. Now if I do the cosine of 70, notice we get positive 0.34 back. Okay, and that's because at these two angles of 70 degrees and 110 degrees, I either went right that far, the x cosine is the x value, or I went left that same distance. So that's the difference between the positive and negative. In this case, I went left 0.34 units. In this case, I went right 0.34 units. Okay, but notice again, the whole idea here is to notice that the sine and cosine of a regular angle and the sine and cosine of their reference angles end up being the same. It's just a difference of positive and negative. The reference angle will always be positive every single time because you're dealing with an angle less than 90 degrees. All right, it's the original angle that may be positive or negative based on the trig function you're working with and which quadrant the original angle is in. Okay, in any event, let's punch the rest of these in and again just kind of validate that. So look, sine of 235. What's that? The third quadrant, so I would expect this to be negative, negative 0.82. And I would expect sine of 55 then in the first quadrant to be positive 0.82, but let's see. And sure enough, it is. Okay. Cosine is negative in the third quadrant, so I would expect this to be negative. Cosine of 235 is negative 0.57-ish. And the cosine of 55 is positive 0.57-ish. And the sine of 282 is about negative 0.98. Okay, 282 being in the fourth quadrant, so it makes sense that sine is negative, and what do you suppose sine of 78 degrees is? Well, 0.98, of course. And last up, the cosine of 282 is about 0.21. And that's in the fourth quadrant. It makes sense that the cosine value is positive, and of course the cosine of 78 is also positive 0.21. Okay, so again, reference angles and regular angles go hand in hand. It's again just a measure of the x and y distances from the origin. There's a lot of symmetry at play there, folks. Okay, so get used to reference angles, and that's what the next example is going to help us work with again. Clearly, the absolute value of the sine and cosine are the same for an angle and its reference. This fact can be exploited to produce sine and cosine values for angles if they are known for their references. So here they're telling us, look, remember that cosine of 30 is radical 3 over 2, and the sine of 30 is a half. Determine the following values, okay? So look, basically the way I typically look at these, I'll make a little grid. Okay, 150 degrees takes me into the second quadrant, and that is indeed 30 degrees away from the x-axis, okay? I'm dealing with the cosine function. Cosine of 150 is going to basically be the same as the cosine of 30. I just need to account for the sine of cosine, SIGN, in the second quadrant. Well, in the second quadrant, cosine's negative. So cos 150 equal to the cosine of 30, but it's going to be negative cosine of 30. And now cosine of 30 right here, radical 3 over 2, so we get negative radical 3 over 2. That's that. All right, next up, sine of 150. Again, same angle, same reference. Only difference here is that sine is positive. So I'm going to rewrite this as the positive sine of 30. Okay, so all I'm doing is taking the big angle, rewriting it in terms of the reference angle, and accounting for whether the whole thing is positive or negative based on the trig function and the quadrant we're in. In any event, we get back positive a half here. Okay, 210 puts us into quadrant 3 with, again, a 30-degree reference angle back to the nearest x-axis. So cosine 210 is going to be the same as the cosine of its reference angle, but in quadrant 3, cosine is negative. So again, we're going to get negative radical 3 over 2 back. And for the sine of 210, I'm just using the same diagram on the right-hand side of the screen there. The reference angle is 30. Sine is negative in the third quadrant. So here we will get negative sine of 30, negative 1/2. Okay, again, let's see. Now we're in quadrant 4 for the next two problems. 30 degrees back to the nearest x-axis. Okay, so this cosine is going to become cosine of 30, its reference angle, and it's going to stay positive in quadrant 4. So radical 3 over 2 positive. Whereas sine of 330 will become the sine of 30, its reference angle, but in quadrant 4, sine is negative. So negative 1/2. All right, so again, big angles get matched up with the reference angles, and the 30, 45, 60 are kind of our big reference angles that we're kind of expected to know, particularly as we move on to like pre-calc and calculus. You got to know those values by heart, okay? These radical 3 over 2s, radical 2 over 2s, 1/2s, you got to know those. Okay, so good stuff to practice. And let's see, last of the lesson problems coming up here, we should not forget that the trig functions are valid for radians as well. Practice evaluating these for each of the following radian inputs. If you prefer, you can convert to degrees. That's probably going to be the easiest thing to do. So to do that, we're going to multiply by 180 degrees over pi, right? And here we get sine of 180 over 2 is the sine of 90 degrees. Okay, so we converted pi over 2 to 90. That's going to be a quadrantal because it's a multiple of 90. That's up here. And the point would be 0, 1. Sine goes with y. The y coordinate is 1. There we go. Okay, sine of pi over 2 is 1. Okay, for pi over 3, let's multiply that by 180 degrees over pi, and we get 180 over 3 is 60. So this becomes the sine of 60 degrees. And that's right in our table above, so you can look up there, but that's radical 3 over 2. All right. Cosine of 3 pi over 2, so again, let's multiply by 180 over pi. Pi's cancel. 180 over 2 is 90, times 3 is 270, so this becomes the cosine of 270 degrees. Again, that's a quadrantal. That's down at the bottom of our unit circle, and that's the point 0, negative 1. Cosine goes with the x value, so the cosine of 3 pi over 2 is 0. And last up for these, multiplying by 180 degrees over pi radians. 180 over 4 is 45, times the 3 up top is 135 degrees. Okay, that puts us into the second quadrant with a reference angle of 45 degrees back to 180. So this is going to be equal to the cosine of 45, but in quadrant 2, cosine is negative. So negative radical 2 over 2 it is. Okay, and again, use that little table I made on the first page to help you out, but I would try your best to memorize that. Okay, homework solutions down below here, so you can pause it, try these, take a look. If you plan on going to pre-calc and calc, you got to be able to do this stuff, okay? So shoot me any questions if you have them. Look through these solutions real quick, or pause, try them, and then look through. Make sure you understand them. Number 4, there wasn't one like 4 in the lesson, so I can talk this through real quick. Well, actually, you could have done this one algebraically. I did this one more geometrically. So most of you will probably do it like I did in the lesson. Okay. In terms of geometry, I drew a circle, and I basically used SOHCAHTOA to draw a right triangle in the third quadrant. Okay, so I put the point in the third quadrant, and you always draw your hypotenuse to the point out of the origin, and you always go back to the x-axis. And then if they tell us cosine is -8/17, well, that's adjacent over hypotenuse. So here's my reference angle. The adjacent side is -8. The hypotenuse was 17. And then you can use Pythagorean's theorem to figure out that this is going to be 15. Notice I made it negative because the y value is going down. Okay, so that's the geometry, but algebraically you're going to use this. And again, just count for the quadrant, get that plus or minus when you take the square root. Okay, and you should get choice 3 back. Okay, and there's number 5. For number 8, instead of converting to degrees, I left in terms of radians. Okay, so you can take a look at that work. Okay, I just got my reference angles, all in terms of pi/3. You could certainly convert that to 60 degrees, that's fine. Okay, number 9, the sine and cosine of an angle will always be between -1 and 1 inclusive, right? Why? Because think about the unit circle, sine of the y values. The highest y value is up at 1, the lowest is up at -1. So the sine values are always between -1 and 1. And the same is true for the x values. And that's the idea with cosine. Cosine will always be between -1 and 1 as well. So any value that's bigger than +1 or less than -1 would never be equal to the sine or cosine of an angle. Okay, and again, just kind of a trickier one to put together here. You can take a look at how I drew my Ferris wheel. Basically centered it like on the axes, drew my 120-degree angle. The hypotenuse is 45, right? It sits 45 feet from the wheel center. Okay, and then I used a reference angle. And the fact, let's see, I used SOHCAHTOA here, sine of 60. I wanted that y value, so I made that opposite over hypotenuse. Okay, so a little bit tricky there. But again, shoot me some emails if you have questions, and I hope everybody's doing well. Take care.